12.3 dot product part 1. We'll have more than one video for this section because there's quite a bit to it. Here's definition. We have ux, uy, uz, which you can call vector u, and vx, vy, vz, you can call vector v. This dot indicates a dot product, and you multiply vectors just by simply multiplying the x components right here, multiply the y components, multiply the z components, add it up. The answer is a scalar. So there's no I, J, or K left in the answer. Exactly what use this is, well, we'll save that for another video. For now, we're just interested in computing the dot product. So for instance, 121.012 gives you 1 times 0 plus 2 times 1 plus 1 times 2, which adds up to 4. Of course, we can have IJK notation, 2i, 3j, 5k, 6i, 10k, 12j. Same as pointy bracket 2, 3, 5, pointy bracket 6, 10, 12. Of course, we multiply and we end up with 12 plus 30 plus 60, which is 102. So some smaller vectors, 10i dot 5i is 10 times 5 or 50. 20j dot 15j is 20 times 15 or 300. K dot 2k is 2. 1 times 2 is 2. 2i dot 10j plus 10k is 0. If you want to think of these as a whole vector times a whole vector, 2i plus 0j plus 0k, 0i plus 10j plus 10k. Okay, so we end up with 3 zeros added together, which give us 0. You can just remember when you have these vectors with only one component, if the components don't match up, you get 0. 5j dot 10k is 0. Here's a definition. U and V are orthogonal if U dot V equals 0. Here are a couple orthogonal pairs. 101.010, 0, we get 0. And 231.-320, we get -6, +6, 0, adds up to be 0. Here's one more case. The 0 vector, 0, 0, 0, which you can indicate as 0 with an arrow over it. I shouldn't say equal. This is 0 with the arrow over it. 0 dot this is obviously 0. This vector is orthogonal to every vector, and even orthogonal to itself. What this means geometrically, well, we have a second video where we'll explain this. For now, it's just a good definition to get used to. So that's all for part 1. We'll be back with part 2 shortly.